Okay, so what I'm gonna do today is I'm gonna show a little bit of how to deal with some different raster type information. So right now in the left-hand side of things, you can see that I have three different types of data. Right now, I've got a USGS 1 meter TIFF data set. I've got an NAD 2002 to 2012 DEM. And then I also have a USGS Mississippi, Alabama 2020 DEM data set. So this one is the one we're going to take a look at right now. The reason we're going to use this one is because it does have just a little bit more elevation change, a little bit more elevation gain than these guys, which are down by the coast. So these ones are for very flat land. Now, with these ones, it is useful to kind of just take a look and see what actually these data sets are. So if I right click on these guys, I can head over into properties. This is just going to give me a little bit of information about the data set that I have. So I can head over into metadata. If a previous group has already put in a little bit of information, then you can take a look at it there. You can also add your own metadata if you are the person who is creating it, and you can do that there. You can also do that in ArcCatalog, but we're not going to talk about that today. So right now, this is just telling you a little bit about where I can find this data. So this is just on my downloads and my hard drive. And then I can go over into here and I can take a look at what I have. So what you can see is that I've got 1 and 1. So this is a 1 meter by 1 meter data set. If I head into the spatial reference, what you can also see is that this is in meters because it does have a projected coordinate system attached to it, in addition to the 1983, the NAD 1983 geographic coordinate system. So this is telling me that this is in meters. If I don't have that, right, so if I do not have a projected coordinate system, then this will be still in decimal degrees. And so it will likely look a little bit different. So this is one of the things you can do, right? So these ones here don't have a projected coordinate system. So if I go into the raster information here, this is saying that it is 0.000095 decimal degrees. So again, this is kind of in and around that 1 meter mark. And so this is telling you essentially how big each one of these different pixels on the ground actually is. So raster data is going to be looking at individual pixels. So if I zoom in really, really close, you can see that it's got a side and a side here. So it turns into a square. This is saying that it is 1 meters by 1 meters. And so this is what that change on the ground is. So 1 meter and then another meter. So each one of those blocks is there. And so this differs compared to something like vector data, which does not have that. Vector data will instead be a line, and a line is a line is a line, and a point is a point is a point as far as you zoom in or zoom out. So this one does change based on that information, essentially how detailed this information can get. So for the purpose of this, a 1 meter resolution digital elevation model is pretty good. Most things are fairly good at that 1 meter range. And so in this case, we're going to take a look at a couple of different things that we can do with this elevation data set. So when you have terrain data sets, you can head over into your analysis ribbon at the top, and you can click on tools. This is going to give you some different things that you can do. So one of the most common things that you can start with is just a hillshade. A hillshade really doesn't do a whole lot other than essentially shines almost some sort of light on this based on some decimal degrees and some sort of altitude. So essentially this is, if the sun was here, what would this look like? Right, and so it's going to create a new data set to do this. So I'm just going to call this hillshade USGS 2019. And I'm going to keep this here for now, and I'm not going to change any of the default factors. So the azimuth is, if I click on this, is saying that it is expressed as positive degrees from 0 to 360, measured clockwise from north. The default is 315 degrees, right? So what that means is that if I start from north, right, I've got 90, 180, 270, and then I've got 315, probably somewhere in this middle zone right here. So basically what this is saying is that if I was shining a light source from high over here across this image heading essentially from the northwest to the southeast, what would this look like? And then the altitude is going from 0 to 90 degrees, right? So 0 being right along the line of the horizon, 90 degrees being directly overhead. Default is 45 degrees. And then the Z factor is if I stretch this, right? If I stretch the Z factor, so if I stretch the elevation by a certain amount, what is that going to do to things, right? Generally speaking, I don't change the Z factor because I have zero interest in doing that. But there are some reasons why you might want to change this azimuth and altitude. But for the purpose of this, we're just going to run this to show you what this looks like. Now, when you're dealing with rasters, it's always going to take a little bit longer to deal with them just because it is a bigger data set, right? So whereas a vector of this size might only have, a couple of lines, even 1,000 lines, right? This one has information every single cell for 1 meter by 1 meter for this entire image. So it just takes a little bit longer. You have to have a bit of patience when you're dealing with rasters, but generally speaking, it does give you some good and some interesting results. So if we take a look at this, right, now we can see kind of what this might look like if we were actually on the ground here, right? So this looks a little bit more like we would typically associate with an elevation compared to this one. This one we know is an elevation, but this one kind of actually looks like an elevation, right? So we can see that we've got hot spots or high spots up through here. Kind of looks like it's some mountainous chain through here. We've got a ridge running through here. We've got a low valley that is kind of running through here. And it looks like it has a river that's running through it, maybe a bit of a larger river coming up through here. We've got another mountain over here. We've got another set of rivers coming down through this way. And then it looks like we've got a road that is coming around this way as well. Now, this road, we can't really see if we have this off, but if we check this one off, then we can kind of see that road pretty nicely. We can also see some of those ridges that are coming across even in this satellite imagery here, but it's much clearer if we take a look at it through here, right? So, but we can very clearly see where those different lines are through there. So this hillshade just gives us a bit of a nice way to look at this data so that we can just strip off some of the different things and take a look at what this might actually look like on the ground, right? Even here, you can see that there might be a bit of a floodplain kicking around in this section, which you can't really see if you're just taking a look at this elevation. You can maybe see it, but maybe not, right? So this is something that just highlights out what those features are. Now, the next thing you can do with this, which is also a good thing when you're dealing specifically with terrain data, is you can take a look at the slope. So this is just going to take a look at how high or what that gradient is going to be, right? So you just search in your geoprocessing tools for that. You put your elevation in, give it a nice name in this case. So I'm just going to give this slope USGS 2019. Now in this case, again, same thing with the other one, you're probably going to want to take a look at where you're actually located. If I have lots of USGS ones, this probably isn't going to help all that much. So just something to keep in mind. So output measurement is in degrees. You can change this. So it's the percent rise. So this is going to be distance over gain, right? So this is the percent of the slope, versus the actual degree of the slope. And then what type do you have it as, geodesic or planar? So again, geodesic being your 3D Earth system, your planar being your 2D system. I'm just going to keep it as planar. And then when you have really big ones, it's just going to tell you, how do you want to do this? Do you want to do this only with your GPU, your graphics processing unit, just with your computer process or central processing unit, GPU, CPU? How do you want to run this thing? And so these ones are just going to give you a little bit of information about what that slope is, right? So we can already tell that we won't have in some of these areas 100% slope, right? We can see that it kind of gradiates down, but it does have some pretty steep slopes that are coming along those ridges, right? And then we also have this nice flat area, and we can see some of the adjustments coming through there. So we're going to kind of have a mix of kind of mid-range slopes, low slopes, and then high slopes. And we can see that it runs, in this case, from this 0, right? So if you have very flat areas like in this river compared to these higher ones where you're in kind of the like 45, 50, 60 range, then this is going to be up kind of in these top sections, right? So slope is kind of also useful because then this is going to give you some degree of understanding of what the complexity or texture of your data is, right? So how complex is this terrain, right? And so you can also see that there's some areas in here which then start to pop out even more, which could be roads, or they could be maybe hiking trails or things like that, or they could just be flat ridges, right? And these ones, even in that hillshade, didn't really crop out very well, right? You can see them, right? You can kind of see some of these trails, but they don't pop out nearly as well as if I have it on this section where there's very clearly some things that are going along these ridges, going along these trails. We don't know if these are roads, we don't know if these are trails, we don't know what these are, but there's something going on in those regions. So again, something kind of interesting that pops out with some new features that you might be able to take a look at and find something interesting that you want to do. This is also useful for taking a look at your, if you want to do like some sort of zonal statistics and figure out what your average slope of an area is. If that average slope has changed, then that might be useful. This might be very, very useful if you're trying to build another road, let's say, because you're probably not going to want to build it on this very steep slope. You're probably going to want to build it somewhere that's a little bit flatter, right? It just takes a little bit less work. So slopes can be useful in figuring out what some of that terrain information is. You can add them into other bits of information as well. So if we were to look actually at how someone is going to calculate the slope, you could do this by hand. Essentially what each one of these pixels does is it takes a look at where its pixels are, what a pixel is in comparison to all of its neighbors, right? So if I have a 0 here and I have 1, 2, 1, 0, 0, 0, then it's just going to compute what essentially the maximum slope of this is compared to all of the surrounding cells. So how far down is it compared to something else? Turn that into degree. Essentially, it's just doing trigonometry and figuring out what that slope is in 3D. Now you could actually turn this into a 3D image. We're not going to do that right now. We're going to save that for another time, but this can be turned into a 3D image as well. So that is slope and hillshade to take a look at. And you can also just layer these out, turn them into kind of a really interesting or nice way of looking at things. So you can head over into the raster layer, you can change the transparency of this, and this is going to then start making it so that you can see your hillshade and your slope in the same thing. You could also reverse that out and do the exact same thing where instead you have your hillshade, which has some transparency attached to it and your slope doesn't, right? So layering these so that you can kind of get a better feel for what is showing up in different areas so that you can kind of almost get a feel for what it looks like on the ground, right? So you can see that you've got these dark areas which then have the high slope attached to it, so it really just pops out what that might look like actually on the ground. So we're going to stop this here and then come back and take a look at some other things like a view shed and what you can do with some of these data sets.